In this video, I'm going to show you the steps to solve systems using the substitution method. In one case, you could have one of the equations be of the form x equals something. For example, the top equation is negative 4x plus 8y equals 32, while the bottom equation is x equals 2y minus 8. Your first step is to substitute for x in the other equation. Because we know x equals 2y minus 8, we can substitute the x in the other equation with that, and it should look like this. Your next step is to solve that new equation for y. And you're going to have a few steps involved. First, you're going to want to distribute to get rid of the parentheses. Then you'll combine like terms. And then you'll have a two-step equation. In the end, for this example, y equals 3. Your next step is, now that you know that y equals 3, substitute that 3 in for one of the y's. And in this case, the second equation looks easier, so that's what it looks like plugged in. Finally, solve that equation for x, and we get x equals negative 2. Your last step, though, don't forget to write it as an ordered pair, x then y. Very similarly, you could also have one of the equations be of the form y equals something. For example, 5x plus 6y equals 46, and y equals negative 3x minus 1. Your first step is to substitute for y in the other equation. So that equation would look like this. The bold is where we substituted. Next step, you would solve that equation for x, and just like if you're solving it for y, you're going to combine like terms after you distribute, and then you'll solve a two-step equation. Now that we know that x equals negative 4, we'd plug it back into one of these two original equations, and then solve for y. And then our final answer, of course, is an ordered pair.